Hello, my lovely students. I hope you had a relaxing spring break. We all certainly deserved it. So here I have, it's listed as 3.1 on the syllabus, but in our book, it's now section 2B roughly, which is also where we placed order of operations. So now we're going to look at combining like terms, and there's a little bit on factorials at the end that I may or may not keep. Okay, so some definitions. A term is a number or the product or quotient of numbers and variables. So this is numbers and variables that are all stuck together with multiplication, or we can have a fraction as well, but no addition or subtraction for a term. It's all the stuff that gets smushed with multiplication, multiplication being the operation that we are the laziest with, and just smush things together instead of writing it. In variable terms, the value of the term will change when different numbers are substituted for the variable. That's why it's called a variable, because it varies. So we don't know what x represents. Could be positive, negative, fraction, really huge, really tiny, square root of 3, and pi, anything. In a constant term, the value of the term will never change. A constant term is literally just a number, no variables at all. That's why it's called constant. The coefficient of the term is the numerical factor of the term. So that's one of those fancy words that we use a lot in math. But the coefficient is the number part of the term, where term is everything that's smushed together with multiplication. Even constant terms, we do consider that number the coefficient, even though there's no variables there. Now, like terms, when we can add these things, we have to be talking about the same kinds of things, exactly the same. So they have to have the same variables, and each of those variables has to have the same power. So we have to have the same letters and the same number of copies of each letter, because that's what the exponent means. It's just more multiplication. Okay, let's do this. So in each expression, because there are no equal signs here, so these are expressions, list the terms and identify each term as a variable term or a constant term. So this is just to reinforce the definitions we just went over. So I have 3 smushed next to m, so that's 3 times m. There's a variable in it, so it's a variable term. Ugh. Variable term. Let's just make that into an arrow. Likewise, the -7n to the 4th, that whole thing, the negative is considered, the minus, I know it's subtraction, but we just think of it as the negative onto the 7. So really, we've got 3 times m plus -7 times n to the 4th, but we could write n, and then plus 11. So that is what we would call the term -7n to the 4th. If I picked up -7n to the 4th and rearranged it, it would be equivalent to what I started with here. But if I just picked 7n to the 4th and moved it, I haven't preserved the subtraction that was written there. So be very careful with your subtraction and moving stuff around. That's one of the mistakes people make a lot in moving stuff around in equations. So just, if it helps you, just always, anytime you have subtraction, just change it right away. Plus a negative. I did that for years. Then our lovely 11 here is the constant term, positive 11. Now, I can write as many constant and variable terms as I want. So I could have plus 11 minus 3 plus 7 minus 4.2. Doesn't matter. We could combine the constant terms as they are like terms because there are no variables on them. So we're going to get to that in a minute. So here, for A's, don't know what A is, so there's a variable term. Then plus 247, and that's all we got. So that is a constant, positive 247. And then minus 31b. So again, negative 31b is another variable term. All right, so variable terms have letters. Constant terms do not. But do pay attention to those minuses, the subtraction and the negative signs. It's very easy to misplace the minus and then the whole problem will. Now, the coefficients, this is where that negative comes into play. If there's subtraction, then that minus sign gets attached to the second number because subtraction is adding the opposite. So you change it to adding, but the opposite always goes, well, sorry, whichever way it is. It always goes to the right. So here, negative 9x plus 17y. So the coefficients, use purple, are negative 9 and positive 17. That coefficient is a ridiculously long word, but negative 9 and then positive 17. We can just write it as a list. Now over here, I have three terms. 23m squared minus 7m plus 5. We are not going to be doing factoring quadratic formula on these, so don't let this freak you out if that's like, you know, making you scared or something. It's just here as an example. We're not going to do factoring. And if you ever have to, Google. Literally, you can type this in, and if it factored, Google will tell you. But our coefficients, we have the 23. Then we have that 7, but because of the subtraction, we're going to consider it negative 7. And the positive 5 is also considered a coefficient, even though there's no variables with it. All right. Now, like terms or unlike terms. So this is the kind of thing that like just discombobulates a lot of people. Like they find it really difficult. So I find for a lot of people at least, I will say the things out loud, and if what I say is the same, or if I can rearrange it so it's the same for the labels, not the number part, just the label, the letters, then they're like terms. So A is 14 A's. That's how I read it. And then I have negative 31 A squareds. So A's and A squares. So regular A's are not the same as square A's. So those are not like terms. Yeah. Now here, 21 ABs and 5 ABs. So they are both AB. Now if I wrote 5BA, multiplication's the same forwards and backwards, so it would be okay if I wrote BA because it means the same as 5AB. And we would still consider them like terms, even though visually they would look a little different. So the order you write the variables in doesn't matter as long as they're all multiplied on the term and they have the same powers. So these guys here are like terms. I could add or subtract them. 412, nice constant term. Negative 3z, not a constant term. Constants and variables are not like terms. I cannot combine those. I may be able to do other things, but I cannot add or subtract them to turn them into one term. All right, D, negative 6x cubes and 28x cubes. So negative 6 thing, 28 same things. Those are like terms. Now, if the numbers were the same and the powers were different, still not like. It is all about focusing, do the variables match? Are they the same exact, like shipping label, if you will? They have to have the same exact label to be able to count them all together so you can be lazy on your inventory sheet. So I'm going to run through this and then we'll flip to the next. No, I'll save for the next video. Okay.